Thanks everybody for being here. Thanks for having me here. Wonderful to be back in Indiana again. It's fun. I feel like I've come to Indiana more times than the other states, so maybe that's unfair, but it's a good state to be. There's so much going on here. It's really exciting. So we're here to give you a little bit of a glimpse of where we're at in terms of soil health testing and practices at NRCS, what some of the efforts are that we're moving forward, because there are going to be huge opportunities over the coming years for everybody to participate. We're trying as much as we can to collaborate with anybody out there who wants to. You know, I feel that soil health is really one of those more the merrier, everybody please get involved kind of endeavors. And as much as we are capable of doing that, we will do that. You know, bring us in, come join us on things. There's just so much opportunity to collaborate, and I feel like if we all go in the same direction, we're really going to make some huge impact. Last session already covered this. You've probably seen the definition many numbers of times, but it's always good to put a definition up there. You know, what is soil health? It's the continued capacity of the soil to function as a vital living ecosystem that sustains plants, animals, and humans. Critical. You know, it's a living system, and we need to manage for a living system, and that's part of the paradigm shift that has been happening there. Our goal really as an agency, and I think really as probably all of us in this room, is to build these win-win regenerative soil health management systems, and for those to become commonplace. You know, that's really my vision. I think a lot of folks' visions is that our new conventional agriculture becomes one of soil health management systems. May seem grandiose. I know we have a lot to figure out. Hopefully together we can do it all. But we're seeing the science is there. The last session in here was talking about the science of the soil health management principles, the how of how you might implement one of these. And really implementing those 4 principles, we can turn our farmland around from that degraded state that a lot of it is in to rebuilding that system, to regenerating the functioning of that soil that we once had through reducing tillage, through more rooting, higher diversity, surface cover. We can rebuild our aggregates, we can rebuild our water holding capacity, our water availability. We can reduce our inputs and the money we're pouring into our systems, and therefore get better profits as well as better resiliency for our production ag. There's just a lot of opportunity there, and we need to put our systems onto this kind of feedback spiral, where the spiral goes upward instead of downward. Some of you may have seen this before, turned on its end, you know, that degradation spiral. The worse you get, the worse you get. Well, we're hoping to turn it around so that the better you get, the easier it is to make the system yet better. But we all know that there are challenges, right? The devil's in the details. We can put those 4 principles in front of you. We know the science is behind them, but how you ultimately implement it on your farm is going to be different depending on the system you're in, the location in the country, the soil type you're in, and it's that devil in the details. Those of you who were here in this morning session and heard Barry talk, you know, he was talking about the corn soybean systems right around here and some of the specific adaptations, the quality no-till, how you adapt that with the right cover crop, the right cash crop, the right nutrient management, the right pest management. How do we do that? If we just look at cover crops, some of the questions that are out there right now is, if you're on a Kansas farm, is there even enough water for a cover crop is a question that gets posed. Well, maybe we can turn that around. How can we invent a system that does allow there to be enough water for that cover crop so that that cover crop can help us bring more water into the system because we're increasing infiltration, increasing water storage, and increasing the access of roots to a larger part of the soil profile so that those plants can really get at all that water. So those kinds of questions, will enough residue remain to suppress weeds? Well, can we build a system where we can have enough residue still in place in the various different climates? How can we economically justify a cover crop when we could just grow high-value crop after high-value crop in some of these California systems? Can we build a system where we meet those principles, but where we don't lose anything? You know, in a range management system, what management efforts are economically worthwhile when the climate is the strongest influence and when there's really very few inputs when you've got 400,000 acres? You know, those kinds of questions need to be tackled. So these kinds of challenges are what we need to tackle as a community. NRCS can do a lot of the application on the land. We can write the science into our practice standards. We can build them into our programs. We can help do some of the science by helping guide it, but we're not a research agency. And so we need the researchers out there to be in constant contact with us and to help us see what it is that you're learning in these local systems so that we can start to address those gaps. So what we're building at NRCS, we've been calling it all sorts of things and like to not give it an acronym because who wants more acronyms? But overall, our efforts in the science of soil health, we are building a structure by which we can collaborate across the various technical arms of our agency to evaluate the existing literature on both the indicators and measures that are the subject of this session, and then how that feeds into the soil health management systems and informing them, how we can adapt those management systems, so the literature component, but also a lot of stuff's not in the literature, and a lot of the stuff will never be in the literature because farmers are always learning. How do we learn from all the existing projects out there, whether they're eventually going to be in the literature or not? How can we leverage all the information being learned, all the skills, all the wisdom that's being gained by people who are adapting on the fly to these conditions? How can we bring that in? We need to leverage those existing projects. We are starting an effort to build and populate the NRCS soils databases with soil health and management data. That's tricky because soil types are defined inherently by what they are that doesn't change. It's a totally different approach. It is what type of soil do you have here? It's not looking at what changes. So what we're trying to build onto that is the aspect of that soil type that does change with management, which is soil health. How can we provide information on this soil type in New Hampshire versus in Kansas versus in Southern California versus in Florida? What is adequate soil health? How do we measure that? How do we interpret that? How high can you go? How low can you go? How high do you need to go to have that adequate functioning? So we're going to try to build into our soils databases an ability to input those data, to learn from those data, and to have that feed into our conservation planning processes. We are monitoring soil health on representative benchmark soils. We're just starting to get that going. I'll get a little more into that. And the most important piece, developing soil health management decision tools and a way to bring in the citizen science, whether that be producers, agricultural larger groups, anybody that can help contribute data. How can we all share data in a way where I know all sorts of people are building databases? Can we get them all to talk to each other? Can we make them all open source? You know, it would be wonderful. That's really ultimately the goal, is to have one place where everything can be pulled together, even if there are multiple out there. And so there are going to be a lot of opportunities for collaboration, but we got to start somewhere. Ultimately, the goal of this is that it's a long-term project or effort that supports the overall objectives of NRCS, but beyond that, because our mission, the mission of our agency, is to help people help the land. We help do that, our partners help do that, we all do it together. How do we move that forward, right? So we need to advance the science that supports that. So whether it's the soil and climate-based interpretations of those measures, the management recommendations that come after that, we're all familiar with this with standard nutrient testing, right? Your pH is low, add some lime. Well, your aggregate stability is low. How do you need to change your system to build those aggregates? You have compaction. Do you have it at the surface? Do you have it at 2 inches? Do you have it at 18 inches? Management for that is going to be different. So we need to figure out what's the status of that soil health, and how do we get you started on the soil health management system so that it doesn't fail because we didn't realize that we had a tillage-addicted soil that you can't just go no-till on. You can't go cold turkey, right? You quit drinking coffee after you drink 10 cups a day, you're going to be in rough shape, right? You take a soil that's been tilled over and over and over again, and you put it straight into no-till with nothing else, well, it's going to flop. It's going to feel pretty rocky, right? So how do we get you on the right track? This is going to add to that. Being able to quantify and communicate the outcomes, right? Whether it's agronomic, environmental, or economic outcomes of these systems, we need to be able to do that, because right now we have innovators who are doing this because they really get it. But there are those folks that just are a bit more risk averse, that are a little more likely to go with the mainstream. How do we make this mainstream, right? How do we target the masses? How do we go from where we are now to where our soil health management system is the new smartphone? right? Everybody's walking around with them now. Who here doesn't have a smartphone? I don't even see a hand. Okay, 10 years ago that answer would have been different. Can we make it there with soil health management systems? Integrating all those tools into what the agency does and into what our partners do, broad nationwide adoption of soil health management systems, that's kind of the goal. So with that, I'm going to let Brandon keep going because he's the one that's been in the field at NRCS and can really kind of speak to the conservation planning process. Right, I should leave you the microphone. Sorry about that.
So yeah, Bianca and I are sharing this presentation, so every other slide we're going to have to switch this mic, so you're just going to have to bear with us. Just kidding. Only happened twice. Yeah, I'm Brandon Smith. I'm the Northeast Region Team Leader for the Soil Health Division. I work for Bianca. And basically I want to just talk with you about what we're doing at the NRCS as it relates to our conservation planning process. Is there any feedback? Because I hear feedback up here. No, you okay? All right. So in the conservation planning process, we generally have a 9-step process that we talk about. And you know, the first step, of course, in any process is to figure out what the problem is. And here in this situation, when we have our planners go out into the field to figure out what the problems are, we're going to give them tools in order to do that. And one of the tools that we'll give them is a resource concerns and planning criteria worksheet that they can work through. And I'll show you that a bit later. The other tool that they can use is an in-field soil health assessment. And so the idea is they can quickly walk out into the field and determine what the issues are and start having the conversation with the farmer about what the farmer's objectives are and how they might be able to fix some of these problems. And then the next step would be to inventory the resources. And at this stage, it would be a good idea then, once you've identified your resource concerns, to actually use some of the laboratory methods, some of the indicators that Bianca will be talking about soon, to drill down and find out some more details about what's going on in the soil and perhaps how you can plan practices to address those constraints. And then you can work your way down through this 9-step process. You can, in step 4, you know, this is an important step because we'll be measuring indicators in the lab, but these have to be interpreted and they have to be specific for soils in a region and different climates. So this will be part of the analyze resource data step. And then we'll plan practices, implement practices, and then we see, you know, a soil health test and assessment being important in actually monitoring the effectiveness of our practices over time. This is something that I think we need to do more of. So I just want to give you a few definitions so we're on the same page. And I do apologize, it's very NRCS-centric talk, but just bear with me. So resource concern is an expected degradation of the soil, water, air, plant, or animal resource base to the extent that the sustainability or intended use of the resource is impaired. Okay, so I talked about in the first step we'd use resource concern and planning criteria worksheet. So that's resource concern, and the planning criteria, these are used to determine whether or not there is a resource concern associated with a specified land use. Okay, and then just 2 other definitions. As part of that worksheet, we'll go through a screening process. Okay, use available information to identify sites that have little or no probability of needing additional treatment to treat a resource concern. So something quick that you can do in the field and say, well, that's not really a resource concern. Let's move on and talk about other things you need to address. And then assessment, we define it by using the word in the definition as the act of assessing the physical condition or extent of management applied. So I want to talk about the resource concerns, and this part's really exciting. We were just able to update the resource concerns. We updated all of the resource concerns for the agency, and these are near final draft. So it's not finalized. But anyways, what we did, if you're familiar with the NRCS resource concerns from before, it used to be we would have soil erosion resource concerns, soil quality resource concerns, water quality, etc. We've simplified that now just to what we call our SWAPA resource concerns, so soil, water, air, plants, animals, and energy resource concerns. So one big subheading. So now all the soil resource concerns are all lumped together. And you can see in black the soil erosion, the former soil erosion resource concerns are relatively the same. In blue, these used to be soil quality resource concerns. Now they're soil health resource concerns, compaction, organic matter depletion, concentration of salts or other chemicals. That hasn't changed. In green is what's changed. These are our new soil health resource concerns. Soil organism habitat loss or degradation, and also aggregate instability. And so we're very excited to have these as resource concerns and integrate them into the planning process within the agency. And again, as Nick mentioned, if you have questions at any point during the presentation, please ask. And so here's just an example of the worksheet and how we'd work through assessing if there is a soil health related problem in the field. So one resource concern as an example would be compaction. Here we give the definition. I won't read it all to you. You can read it. But definitely we're looking at management-induced compaction. And what is our objective? Well, we want to reduce the compaction, right? And here we have our land uses that are associated with that resource concern. Okay, next we look at the screening level. And screening, again, is something simple. It's going to change for each resource concern. But for compaction, you know, the screening level could be as simple as it's not a problem. You talk to the farmer and they don't think it's a problem. And they're not running heavy machinery on the soils when it's wet. And these activities pretty much aren't causing soil compaction problems. So, okay, 95% confidence that soil compaction's not a problem. Then you don't move on and you stop. This is kind of the flow of the planning process. If you make it past the screening level, then you go to the planning criteria. This used to be the assessment level, but it's called planning criteria now. And so then you work through this. Well, do they have a soil health management system? Okay, a collection of soil health practices that have a synergistic effect, not just one soil health practice. Do they have a soil health management system that addresses compaction? Is it being followed? Are there no platy is there no platy structure in the soil or any restrictive layers? Do you see any evidence of you know, thickened roots or J roots, right? When a root hits a compacted plow pan and goes lateral? Or are there no restricted layers exceeding 300 psi using a penetrometer at field capacity? Okay, so roots can't penetrate past 300 pounds per square inch in general, so that's a good sign that you have a problem if the penetration resistance is above 300 psi. And then on the right we have our assessment tools that we will use to figure out the planning criteria. You know, cards, shovels, penetrometer, metal rod. And I have in bold there our in-field soil health assessments, which I'll talk to next. And the in-field soil health assessments are really going to be done all the time before we go to the stage of getting a laboratory test done. In this process of updating the in-field soil health assessments, we sent out a directive to all states, and we asked them to send in all their soil health cards that they have. Each state, since the early 2000s, they've been developing their own kind of way that they go out in the field and they look at the health of the soil in the field. And so here's the survey of all the indicators used on the soil health cards, and this is a frequency, so the percent of the time that the indicator was shown on the card. And the ones in the green are the ones where 50% or more of the time these indicators showed up on the card. And you can see that soil pH actually was one that was used quite frequently, as well as crop vigor and the color of the soil as an indicator of soil organic matter. Erosion, interestingly, was on a lot of cards as an indicator of soil health. Condition of the roots and shoots, how well the surface was covered with residue. Earthworm counts were very big. Most of the cards had earthworm counts. aggregate stability or structure, some other way to identify aggregation in the soil or tilth. Infiltration. Some folks were actually measuring water infiltration using infiltration rings. Others were just providing an estimate of infiltration. And then, of course, compaction. Nearly all the cards were measuring compaction. So in a draft state now, we have a infield soil health assessment card that we're looking at with these particular indicators or assessments that we'll use in the field. So residue cover, breakdown of residue, aggregate stability, compaction, surface crusting, roots and pores, general biological activity, and soil color as well. So you've seen all of these in that previous figure, and these are the ones that are primary candidates right now for our national infield soil health assessment. And so basically what this assessment is going to do and help us in the field diagnose problems is we'll work through another worksheet like this where, okay, your indicator, let's say it's surface crusting, for instance. What is it? Well, we describe it, the crust that forms after a rain and drying event. And then here we'll list the resource concern that is addressed if you improve soil crusting or get rid of soil crusting. So here we have 3 resource concerns that are likely influenced or a result of surface crusting. We have the methods to assess. Typically evaluate after the soil dries. One good way to do it is just visually, looking for evidence of ponding or interview the farmer or looking at crop emergence. And then, procedures for validation, take a photo or just look at it and document it. And then we really wanted sort of a binary approach at the end to just say yes or no. Is it a resource concern or not? We work in the environment and nothing's black and white outside. And you can always say, well, it's kind of this, kind of that, somewhere in the middle. And we just wanted to have it be more concrete and say, is it a problem? Yes or no. So I'll turn it back over to Bianca for a bit. That's the beginning stages, and she'll talk about some of the next stages.
So as timelines always go, we're told that we need to provide a final of this to input into our CDSI, our Conservation Desktop Streamlining Initiative, something that'll have it available as a cloud tool to all planners supposedly by September of next year. I'm really hoping that happens. That would be very exciting. In the meantime, we'll have it available, by that date, certainly on paper. And we hope to collaborate with folks. We hope to get input from people. And then we'll get into the next steps, right? So this is that first level. Everybody can do this. Every farmer could do this on their field. Simple, in-field, at least we have an idea. But when it gets to actually assessing how well are these practices working, do we really have that constraint, and how does it compare to a different constraint? Well, we might need another level there. And so evaluating, to begin with, where we're at in terms of the literature and existing projects, what indicators and preferred methods can we choose that are out there right now as laboratory methods has been one of the primary defined needs. We right now have an internal white paper that's actually no longer in review with NIFA and ARS. I forgot to change that. So as of this last Monday, NIFA and ARS reviewed that white paper and said, you know what, this looks good, we're on board with this. So we as USDA will be moving forward with the set of indicators that we put together in that paper that is a first cut, current best available, up for change over time as we improve the science set of methods. The idea is that we will hopefully get others on board with that set of methods to begin with, so that we can build a data set where when somebody measures aggregate stability, we can actually compare the numbers. If there's 5 organizations in Indiana all measuring aggregate stability for whatever they're doing, we can pool all that data into one data set and really learn, for this soil type, what's an appropriate aggregate stability that we need to get to? And we don't have that right now because there's a lot of gaps in that. We're going to be doing a much more rigorous meta-analysis of what data are currently in the literature so that we can get at preliminary scoring functions. We actually have an agreement with ARS, and they're going to be working with us on that over the coming years. We're developing metadata needs so that we really know what data do we need to be collecting from farmers about their management and about other, the soil type and whatever other data, so that we can really interpret the soil health data that come out of this. And then kind of gathering insights from regional cropping systems for the adaptation of soil health management systems and implementation. It's all part of that first component. In terms of assessment, soil health assessment, which means not just the measurement and getting a value, but actually interpreting that value and understanding what it means, and then monitoring. Those protocols for that really are largely non-existent at the national level, and they haven't been standardized beyond nutrient testing. And even, nutrient testing, we've got standards within states. Some states share them. There's a lot of diversity there. What we're trying to do is look at some of those gaps. What are we currently not measuring? And head off a situation where we have 10, 20 different ways of measuring it across the country, wherever that's possible, so that we can all pool those data. Sampling protocols differ, indicator choice differs, laboratory methodology differs, the interpretation of the numbers that come out, the management recommendations. And the further down you get, the interpretation and management recommendations, it is absolutely critical that that is adapted at the local level. But in terms of how we sample and what we measure, what indicator we pick, and what the method is, the more we can standardize that, the more we're going to be able to share data and much more rapidly move forward. And the more we're going to be able to put in place a process where if somebody discovers a new indicator or a new method for something that really works much better than what we have in place, well, we find how we can align those with each other. Is there a good correlation between them? Can we translate old data into new data? We phase in a new indicator. That's all in the realm of possibility. But we need to start with something that's standard, especially for a national agency where it's really difficult to deal with all these different things that are out there for what we do. Some of the criteria for indicators, they really, sort of from the scientific level, need to be scientifically, agronomically, and environmentally relevant. They need to represent diverse processes. So, whether we're looking at compaction, whether we're looking at the ability of aggregates to remain stable, whether we're looking at carbon sequestration, biological activity, various processes that work through that biological activity, that's what we mean with diverse processes. They need to be sensitive to agricultural management, because soil health is all about how we, with our management, impact the functioning of the soil. So whatever we measure, it has to show that difference. When we measure blood pressure, we know we're doing that because that's impacted, and that tells us something about our health. And so this is similar to your blood pressure, your iron count, whether you're anemic or not, that kind of thing, trying to get a pulse on the health of our soils. We need to have those be standardized methods. They need to have an ability to show fairly short-term change. We heard this morning multiple times, about 3 to 5 years is what it takes to get from a degraded soil to where you're starting to see some differences. So with 3 to 5 years of a change in management, we should see those differences in indicators. But there's some other criteria that are really critical, right? So these indicators really need to be easy and inexpensive to sample and measure. They need to be repeatable in a lab. And ideally, the infrastructure and our investment in being able to measure those would be fairly minimal, because this is something where if it's not accessible to the general public, if it's not accessible to farmers, then we don't have that next set of soil testing that we're looking for right now. So it needs to be able to be something that can be measured by public and private labs, can be offered to the public. The interpretations really need to be accessible to many users. So where we really understand the processes of the soil well, we need to have some indicators that give us information about how well that soil is functioning so that we can make those interpretations, and it needs to be actionable. We need to be able to say, just like with pH, you've got low pH, we need you to apply lime. Well, we've got low aggregate stability, we need you to build that aggregation. Okay, here are some recommendations, here are some ways to go about that. So we identified a number of processes that have to be functioning, whether that's organic matter cycling and carbon sequestration, soil structural stability and water partitioning, general microbial activity, how alive is that soil, carbon food source, how well are we feeding those microbes, are we feeding them a diversity of those carbonaceous materials, bioavailable nitrogen, right? Most of our nitrogen is in proteins in the soil. That's where it is. How do we get at that? Microbial community structure and diversity. So we tried to target those processes, and in collaboration with Noble and Farm Foundation, who funded a lot of the initial meetings, built the Soil Renaissance. NRCS was a huge partner in that. We led the measurements committee, and we brought a whole bunch of people together, and that was the beginning of this effort. Basically, the straw papers that came out of that, out of the first meeting of the Soil Health Institute, we were then able to pull that information into this internal white paper to say, okay, let's get all of our NRCS technical folks on board with what methods would work for NRCS to do this, and then let's go out and get feedback. So what we've come up with is we've chosen a preferred method for each of these processes. So for organic matter cycling and carbon sequestration, there's a whole lot of methods out there, but the preferred method is dry combustion soil organic carbon. For aggregation, there's a whole number of methods that are being used out there, but the most widely used method all across the scientific literature, has been done all across the country, is the ARS wet aggregate stability method. Kemper and Rosenau, and there's a bit of information on that there. For short-term carbon utilization or respiration, there's a number of CO2 respiration methods out there. It's really critical that it's long enough because there's a lot of variability when you just do 24 days. So a 4-day incubation is what we picked as the preferred method there. There's a number of enzyme indicators, and there are some folks that understand those a whole lot better, and those are part of the preferred methods. Those are not currently available in labs, but there's a lot of potential for that. So for what we're doing in NRCS, really kind of trying to gather these data, seeing what is the most useful, what we can get the best interpretation out. You'll see we're actually going to incorporate some indicators that right now there's not as much known about them as you'd like, but we believe we can fill the gaps and really kind of get down to some of these other processes that we don't have in our better known indicators. So that's why you'll see some of the enzymes in there. There's been a lot of work done on those over the years. Readily available carbon pool. How well are we feeding those microbes? The permanganate oxidizable carbon method is defined as the preferred method there. For bioavailable nitrogen, the preferred method is a modified from Wright and Upadhyaya, a autoclaved citrate extractable protein method. And then for community structure, and this is where there's the most debate, still not figured out whether it'll be both phospholipid fatty acid and ester-linked fatty acid method or one of those. And so there's a lot of discussion there to be had. So that's what we've got in this white paper as our preferred methods. We'll be using those in our first set of data that we collect. ARS is working to incorporate those into their long-term work, so the LTAR sites, for example, GraceNet. NIFA is working on incorporating those methods into some of the RFPs for researchers that they roll out so that we can get university partners involved in testing these, developing data sets, giving us those data back. So hopefully we'll be able to compile all those data sets, and over time we'll get from the initial pilot scoring functions that give us that initial pilot interpretation that we can get out of reviewing all the literature that are out there, and we'll move forward from there as we collect a consistent data set across the country, all using exactly the same methods. We'll put more data behind that, we'll put more interpretations behind that. We would really like as many folks as possible to contribute to that effort. The idea behind it, just to reiterate again, this is a very common, everybody's been using soil testing in this way kind of framework, where you test your soil, you figure out what the constraint is, and you manage that particular constraint. You have a problem, you manage to fix that problem. And so, for example, if you've got aggregate stability, it's 10% stable, on some scale that might be a 20 out of a 0 to 100% scale, the interpretation might be that aggregate stability is too low for that soil type and that climate, and so is identified as a resource concern. Therefore, we need to manage to fix that. And that's where it's going to come, where it's going to get a little tricky, because how do you fix that in potatoes in Idaho? How do you fix that in potatoes in Maine? How do you fix it in corn in Indiana, or in tomatoes in Florida, or in rice, if we're going to go to rice? You know, there's a lot of tricky things to figure out, right? But that is where the rubber is going to hit the road. But before we can do anything with these indicators, we need to actually have an idea of what's a normal range. How high can we go? How low is too low? And for that, you know, really we want everybody involved. We want this to be a management decision support system so that we can help our producers with data and with everything else we know in the field to adjust their management systems so that they can monitor those and improve them over time. Just a little bit about scoring methods, right? A lot of what we're used to right now in terms of soil testing is what we know about nutrients. With nutrients, it's very clear. We identify the constraint right now. Your phosphorus is too low. We add some phosphorus. Bam, your crop is better. Gosh, wasn't that quick and easy? It's not going to be that easy with soil health. It took us a long time to degrade our soil to where it is right now. It's going to take a bit of time to go back up to where we are. And we have the challenge that we don't have curves like this yet. We can't say, you know, for this low a nutrient level, it's too low, and then here we're in the optimum range, and if we start applying more, we're going to go downhill. We don't have that yet. That's part of what we need to collect. And so the way that we can start up with that is more like the way that the medical community deals with a lot of data, which is we know that blood pressure is in a normal range from here to here. Only that it's different for different soils and different climates. So that here to here is going to be different across the country, which is why we want to tie it into our soil survey, so that when somebody goes online and sees that Honeoye silt loam or whatever, Buxton silt loam, whatever it may be, you're going to go in there and you're going to say, okay, well, I just measured this from my local lab that uses this method. Okay, for this soil type, soil survey can now tell me that this is low, this is high, this is good, wherever it may be, right? So it's going to be an approach of saying, okay, some indicators are better when they're higher, some indicators are better when they're lower, and some indicators have an optimum, and that's going to be inbuilt into the system so that that interpretation can spit out, but so that it's transparent for those folks that really want to understand what's behind the scenes. And this is how that differs, right? If we just look at, for example, a Georgia Altisol versus an Iowa Mollisol, this comes out of the SMAF framework, which has been in the research world for a long time. Those of you who are researchers may know much about this, but you know, it's really not used by farmers because it's an Excel spreadsheet. But just for organic matter, you know, if you have 0 to 2%, if you have 2% in that Georgia Altisol, that may be very good organic matter. Or maybe we'll find that we can actually go a lot higher. We'll see as we do this. But if you have 2% in an Iowa Mollisol, gosh, that is really poor, and you really need to up your game, right? So that's the kind of difference we're talking about. So with that, I think, nope, I'm not handing back to Brandon. I just wanted to put that back up there, right? It's all part of this conservation planning process where we really kind of go all the way from identifying the process to planning, to implementing, and then evaluating with those much more objective, much more quantitative indicators, where if we go into the field and do that visually, well, we can definitely get somewhere. It's a really good first tool, but if we can collect these kinds of data over time, I think we'll be a lot better off. So building and populating the NRCS soils databases with these data, that's the plan. We need to get our IT on board and need to actually get that funded. Anybody who really cares about those things, well, you might know better who to push than we do. Need to get that funded, need to get that going, but the plan is to build those databases. We really want those databases to be able to populate from multiple different sources, right? Whether it's from the literature, from existing projects, from our own benchmark sites that I'll talk about for a moment, from NRCS field financial and technical assistance efforts, from citizen scientists, from other agencies and partners. We'd love for those to all somehow come together so that we can make the best use of that. In terms of the benchmark sites, the idea is to kind of target, once we know more where the gaps are, to target some of those gaps around the country and collect more data there. We've got a few of those funded for this year, and some cooperators are going to start this winter to plan those studies. We think that there'll be further of those in the future, a few at a time, depending what funding becomes available. But again, we can't do it all. We're one agency. there's limited funds. If all of us can work together on these kinds of efforts, I think we'll be a lot better off. I think here's where the rubber hits the road. This is the absolute most important part, right? Creating field tools that conservation planners, farmers, agricultural service providers, industry can use, where everybody has access to the same methods, where there are public labs out there that can run them, because if we can create a government and the industry shared set of standards and learn based on those and update those over time, people will pick it up. That won't, that way we won't waste a bunch of resources with everybody doing different things and adjusting all the time. Getting that into our NRCS tools, but getting it into partner tools. Building apps that can help feed data. Those farmers that are really willing to share their data, that are out there all the time, digging in their fields, that are sending samples off, that work with ag service providers that want to learn. I think we'll all learn better together if we create mechanisms to really do that. And really engaging stakeholders in that process will be absolutely critical. So with that, I'm going to hand back to Brandon. I will actually hand off the microphone this time. He'll talk a little bit about actually planning those practices in the field.
Okay, thanks. Yeah, just a little bit on the infield planning. So, the overall goal is to use both the infield assessment and the laboratory assessments to help make management decisions. And I think the question has come up a lot, why do you need a laboratory assessment? Why can't a shovel just do it? Why can't you just go out there and visually observe what's going on and plan a practice from that? And I think the idea really is that there are things going on in the soil that aren't readily discernible just to the naked eye. You actually have to measure them, okay? And we know this because we measure phosphorus in the soil, potassium, right? Calcium, magnesium. There are things we need to measure, organic matter. So, it's got to be both that we use. And one of the key things, we did these plans in New Hampshire based off of the Cornell Soil Health Assessment. And one of the great things about that is that it provided the producer with this holistic report about what was going on in their soil. So the physical, biological, and chemical properties. And really started getting them to think about what is the group of practices, what is the suite of practices we need to use to improve our soil health. And so I think this really helps, in general, getting producers to adopt a soil health management system. Our goal really is to provide those technical specifications to our planners and producers and really help target them, guide them to the conservation practices that they need to use. So we'll be doing that as part of a technical note that will come out through the agency in association with all this other work that we're doing. And then lastly, as I mentioned before, this is going to really help us monitor the practices and definitely help us when we report out on the effectiveness of the practices and financial assistance dollars. I got this off of Colorado's field office technical guide, but this is just an example of what it would look like in the technical note that we produce. Here's your resource concern again, like Bianca showed, aggregate instability. Here's some things that you can do in the management practices you can do in the short term to address aggregate instability, some long-term strategies to address aggregate instability, and then the list of NRCS practices that are associated with these short and long-term management practices. So I just want to actually show you some of the practices. So NRCS has a 5-year cycle where we update our practice standards. And over the past couple of years, we've really been updating them to include soil health as one of the purposes in the standards. So I'm going to show you 3 slides with all the practices that are agronomic that have soil health as a purpose. And I actually want to, if you pay attention, I want you to see if there's any missing too in this. If there's any missing, please tell me. So one of the most important ones we know is cover crop, right? That really is key in improving soil health. Having a legume cover crop is one of the best ways to improve soil health, right? Conservation crop rotation, Barry talked about that a bit. You know, we see soil health highlighted in blue there, and it's all pretty much saying the same thing for these practices, for our residue management practices, maintain or increase soil health and organic matter content. And these are our primary practices. Prescribed grazing, a great soil health practice. Grazing cover crops, also a great practice. And then lastly, integrated pest management. So the agency is also coming out with new IPM practice standards, and hopefully we can use these new standards really as part of this holistic soil health management system approach to improve soil health. So here's some of the secondary practices. Controlled traffic farming, right? For reducing compaction and improving soil health. One of the newer practices, amending soil properties with gypsum products, right? We've got a couple purposes here. Not only by getting rid of some of the available aluminum in the soil that's causing toxicity, but also by improving maybe some of the physical properties in the soil and helping with infiltration. Mulching, certainly on different crops, this is a good practice to increase, maintain or increase organic matter content. And then conservation cover, pretty much for land, maybe that's in pollinator habitat or not necessarily in active crop production. This is one of the better practices that will help improve soil health, because you're going to leave that on there for a certain number of years, give the soil a rest with a diverse species. And so that's a diverse mix of species. So that's a great way to improve soil health, as well as forage and biomass planting and silvopasture. And then some of the other secondary practices we have are really related to salinity and sodicity. And these aren't really in my wheelhouse per se, but in the Northeast. But you know, salinity and sodicity management, subsurface drain, irrigation water management, and sprinkler system. These are all used to try to get rid of excess salts in the soil that are causing problems with nutrient uptake, crusting, and other problems that are happening in the root zone. Let's see. So with that said, did I miss any practices, any obvious ones?
I didn't see nutrient management. You did?
No, I didn't. I didn't have 590. Why do you think 590 should be in there?
Well,
Nutrient management.
chemical soil quality was still part of it, right?
Okay.
I mean, I didn't see it.
You didn't see it.
I didn't see that practice on the list.
It wasn't.
Okay. It should be.
It should be. So why should it be?
Why wouldn't it be?
Well, I asked first.
Well, nutrients can come from chemicals applied, but they also can be recycled to the organic pool.
Okay.
I think we need to know how much per meter.
Okay. Good. And I'm actually soliciting input right now. Yeah.
I would put it in the context of precision nutrient input.
How so? Precision nutrient
So
inputs.
you're finding what you need where you need it,
Mhm.
sort of excess here and not enough there. So
So would that be different from the 4R strategy much, or the 4R? Right place, right time, right source, right method.
no, I mean it's that, but
Right.
I mean, precision ag captures all of that.
Right. Right. Okay.
You know, if you're looking at the holistic approach of nutrient budget, then you need to add also the cover crops. Nutrients is coming from cover crops. Nutrients is coming from composting or mulching. Nutrients is coming from, you know, other sources as well, not just chemicals. So
Nutrients are coming from other sources, not just chemicals.
Kind of holistic approach of nutrient management
Sure. But
instead of just 4R strategy.
so we do have a little bit of time, so I just want to pose this question to you. From this angle, how does nutrient management improve soil health? Not how does soil health improve nutrient management, but how does nutrient management improve soil health?
And I like to remember something David Grant has been telling me for many years now. He's improved the amount of nutrients that's contained in the organic pool, use cover crops and recycling the nutrients, and it greatly reduced the amount of nutrients it had to apply and made the systems much more cost, makes more profit.
Right.
For doing that.
Through the cover crop.
In a large way.
Mm-hmm.
And by building an organic pool, he's actually dropped, maybe applying 150 units of nitrogen to 25.
Yeah.
Because it's all in the organic pool. If you don't know that, you're missing a big quality,
Yeah.
part of soil quality.
Yeah.
You're making a lot of money doing that.
Yep. Yeah, that's a good
He's
point.
done that fast. I mean, in some of these farms I've been on, even within 7 years of acquiring a new farm, he's gone from the Cardington soil, which is pretty common in his area, went from 150 to 25 units of applied. He was proud of that.
Oh, I'm sure.
I went out to visit him when we had our furlough in 13. He asked me to get up in the combine. You see that monitor out there? It's 250 bushels of corn coming out. He said, I put on 25 units of nitrogen. That's, well, was that good? I think we all know it.
Yeah, exactly. There was another question over here, or a statement.
Comment, you asked how nutrient management would be part of it. Well, I doesn't believe that we over-apply the nutrients. So therefore, by over-applying the nutrients, we're hurting the microbiome soil. So to me, just the regular soil nutrient amounts that are accepted as norm, to me, is too high.
Mm-hmm.
As a typical operation, we're applying too much nutrients.
Mm-hmm.
And we're not allowing for our soil health to go, to build its, its need to be used.
Mm-hmm. So providing adequate amount of nutrients, but not excessive? Would you agree?
Well, that's an argument between what's adequate and what's necessary.
Sure, sure. Okay.
And that's where my big argument is.
Okay, I got you.
One of the,
Oh, I'm sorry. Can everyone in the back hear? Do I need to repeat, or? Yes, I need to repeat? No. Maybe I need to repeat. No, I'm good. Okay. All right. Was there any other comments? In the back? Yeah.
Your primary practice, you had 528.
Yeah.
So maybe under secondary, you might add fences, pipeline, water utility as a secondary practice to support the primary practice.
Yeah, and that's a good point. I think we consider them associated practices, not necessarily secondary practices, if you can draw that distinction between the two. But yeah, you're right. Fence on its own does not improve soil quality, but when used with prescribed grazing, it will, yeah.
And I'm thinking temporary in terms of crop field, so we can cover crop and grades.
Right, right. Did I see another question out back there too? Yeah?
How about manure and other organic resources that we recycle?
Can you expand on that?
Certainly that adds organic matter to the soil, it changes the biology of the soil,
Mm-hmm.
it changes the physical properties.
Yeah, sure. Agreed. And so in the nutrient management standard, we already talk about, applying the right amount of manure, we have the phosphorus index and et cetera. So that fits, but how does that fit within the standard of?
In that standard, it focuses on the recycling of the nutrients, it does not focus on the utilization of the organic matter and the benefits that provides to the soil system.
There you go. Okay, thanks. Yeah.
You don't have it today, but someday I think we want to have perennial rains up there as the Forever Green Initiative really comes to fruition. Research that's going on.
Yeah, that's a good point. All right, I'll leave it there. And that's, I wanted someone to know that nutrient management wasn't up there, and I wanted this, to progress. So anyways, I'll leave it there. Bianca can come back up, but I will say beyond the practices, one of the things that we've actually been working on this week, which is in draft form, is we have approval to go ahead with the Soil Health Conservation Activity Plan. So this will be a a plan that's written by generally technical service providers, certified crop advisors. So that's very exciting. We've been trying to do this for over 5 years now, and we finally have the opportunity. So, so look forward to that in the next fiscal year.
Brandon, I just want to say you make a great devil's advocate. Watch the Federal Register. Give us input on the 590. 590 is always a tricky one. If you have soil health related input, please, please, please submit it. Submit it copiously, because it'd be good to get serious public input on that one. Okay, so anticipated outcomes of all of this effort. You know, really, a lot of this, if we can standardize the way that we measure soil health between government and industry and across the country, how much more can we learn and how much faster can we move soil health forward? If we can incentivize and facilitate public availability of testing, our farmers will actually see something that they can read that says, your soil health isn't adequate, you need to manage it. I mean, what farmer right now looks at a soil test report that says your pH is low, your phosphorus is low, and I'm not going to apply anything to get my corn, right? I mean, corn's a valuable crop. You want to make sure that you manage it right and that you give it what it needs, right? And what every farmer that manages economically is used to is looking at those numbers and making sure that things are in the right range. Well, soil health is severely degraded in much of the country, and being able to give the average producer that farms what is today's conventional a report that says, looking at the whole functioning of your soil, here's how it's functioning or not, here's what you could do. We really think that that could have a lot of opportunity, especially if everybody's on the same page, right? So if we have that data that we can share, that everybody's kind of looking at the same data with actionable, easily understood results, and we can integrate that, I think a consistent message to farmers, whether it's coming from NRCS or Extension, or whether it's coming from the farmer next door, their son, their grandfather, the local co-op, the coffee shop. You know, what if the coffee shop talked about, my aggregate stability is this, what's yours? You know? I think we could get somewhere with that. So that's really what I want to see happen. And we think that this effort will get things in the right direction, especially if we can get a whole lot of folks collaborating with us. So lots of opportunity. I think there's a lot of benefits to come of this. The benefits are huge. We've been talking about them all day. You can read them. I'm not going to read them off to you. But I mean, we're investing in our nation's soil health here. And I think that there's going to be a huge return on that investment if we do it right. Let's do it right. Let's do it together. Let's all go in the same direction.